Good morning, children. In our last class, in the lesson electricity, we have learned how to find out the total resistance when the resistors are connected in series or parallel or both. And today, the same series and parallel resistors we are connecting across a circuit. And our main task of today is how to calculate the current and how to calculate the potential difference across each of the resistors. Let us see. Here, this is the battery, first cell, second cell and last two cells. This middle line indicates that how many number of cells are there we do not know. So this is the battery, the total potential difference is 10 and that is a switch and it is resistor 1 5 ohms and next two resistors R2 and R3 both are in a parallel connection and connected by an emitter. Our first question is calculate resistance of R2 and R2 plus R3. R2, R3, we have to find out the total resistance here. What these two resistors R2 and R3 both are in parallel connection. So to solve it, given R2 is 2 ohms, R2 is 2 ohms, R3 is 4 ohms, R3 is 4 ohms. Since these two are in parallel connection, the connection is parallel. So according to the formula of total resistance of parallel connections, we will get 1 by R is equal to 1 by R2 plus 1 by R3. 1 by R2 plus 1 by R3. That is equal to 1 by 2 plus 1 by 4 because the value of R2 is 2 and value of R3 is 4. Taking LCM 4, you will get the numerator 2 plus 1 or that is 3 by 4. And once you reverse, take the reciprocal of 1 by R, that is here 1 by R is 3 by 4, reciprocal is R by 1 is equal to 4 by 3. So the total resistance of R2 plus R3 is 4 by 3 ohms. And let's go to question number 2. And now the second bit is total resistance, calculate resistance R1 plus R2 plus R3. R1, R2, R3, these three are you have to calculate. Even if the single step is given, you cannot able to add R1, R2, R3 directly. First R2, R3, since they are in parallel connection, you need to calculate first the total resistance of R2, R3, then you have to add with R1. So coming to the second question, that is resistance of R1, R2, the total resistance. It is given that R1 is 5 ohms, R1 is 5 ohms and R2 plus R3 is 4 by 3 because R2, R3 together you have to take since they are in parallel connection. And in our first bit we got R2 plus R3 is 4 by 3 ohms. So I wrote R2 plus R3 is 4 by 3 ohms. And the connection is now R1 is connected in series with R2 plus R3. R1 is connected in series with this total resistance. So this resistance is in series. So I have written R2 and R3 in braces. So since the connection is a series, total resistance is the simple addition R1 plus R2 plus R3 within braces. The value of R1 is 5, value of R1 is 5 and R2 plus R3 that is 4 by 3. On adding it's got 19 by 3. So the total resistance of R1 plus R2 plus R3 is 19 by 3 ohms. And now our third question is reading of the emitter. Look at the circuit. Circuit is in the circuit A is here. So A is the emitter and it is going to calculate the current in the entire circuit. Total circuit it is going to calculate or measure the current of the circuit. So to know that, let's see, because it is the case of circuit, for the entire circuit the resistance is R. There are three resistors there, R1, R2, R3 and together R1, R2, R3 we got 19 by 3 ohms. So for the entire circuit, potential difference is 10 volts. Potential difference is given 10 volts and resistance is 19 by 3 ohms and we have to calculate the current I question mark. From Ohm's law we know that V equals to IR. So if V equals to IR, then I equals to V by R. Substituting the value of V and R, that is 10 divided by 19 by 3, you got the value of current is 30 by 19 amperes or 111 by 19 amperes. Now to the existing circuit, I have connected 2 voltmeters and 2 emitters to know that what is the potential difference across R1 resistor and what is the potential difference V2 across R2 and R3. Similarly, what is the current at A1 and A2. In our next video, you will see that how the values of V1, V2 and A1, A2 changes as the current moves in series and parallel connection. Keep watching our second video. Thank you.